if we don't really need to invest in lots of new capacity, all this building of new power plants that people are sort of anticipating, it might not be needed if we can get more out of the existing grid.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software.
Hello, and welcome to This Week in Green Software, the show where we unpack the biggest stories shaping sustainable software and talk through what they actually mean for builders, operators, leaders, and communities. I'm Tzviya Sigmund, and today's episode is all about how world events affect energy. Legislation in the U.S., wars overseas have tremendous effects on the cost and utilization. Joining me today are Kate and our guest, Ryan Sholin from Electricity Maps. Kate, would you introduce yourself, please?
Hi, everyone. My name is Kate Goldenring, and I am a senior software engineer at Akamai, where I focus on building platforms that scale to zero. And beyond that, I work in the WebAssembly space and serve as co-chair of the Documentation Special Interest Group within the Bytecode Alliance. And I'm looking forward to talking more about software sustainability this week.
Thank you. Ryan, go ahead.
Hey, so glad to be here. Thanks so much. I'm Ryan Sholin, a strategic account manager and advocacy lead at Electricity Maps, where I work with some hyperscalers like Google and Microsoft and others. And I've also been involved for the past year or so as a contributor at some other organizations like the Green Software Foundation and the W3C, working on sustainability standards, specifications, and guidelines.
Thank you. Before we dive in, here's a reminder that everything we talk about today will be linked in the show notes below the episode. So let's get started. Ryan brought some news stories to share with us today. The first one is Grid Utilization Coalition and Virginia legislation. Ryan, do you want to share what that's about?
Sure. This was just announced a couple days ago when we're recording this, and I thought it was really interesting. It's Google, Tesla, and some other companies that are partnering to try and get more out of the existing grid in highly constrained locations like Virginia in the PJM grid region in the US, which happens to be where I'm located, kind of in Data Center Alley here. It's like another flavor of flexibility. It's really looking at the overall grid capacity and trying to measure and to better figure out if we're really using everything that the current wires and transmission and distribution and substations and generation allow us to do. The positives that could come out of that are a clearer view of demand. And for those companies like Google and Tesla getting involved, it really helps them if it allows them to connect to the grid more quickly. That constraint has been a big conversation when it comes to energy and data centers and AI and all this load growth that we're seeing, demand growth. And for consumers, it helps keep electricity prices down if we don't really need to invest all of this if we don't really need to invest in lots of new capacity, all this building of new power plants that people are sort of anticipating, it might not be needed if we can get more out of the existing grid.
Thank you. What I found most interesting about the article you shared was a discussion about the denominator effect. Do you think that you could explain that in a little bit more detail?
Sure. I think the denominator in this case is really the overall capacity of the grid. So when we talk about what we're building the grid for, it's not like we're going to use every ounce of energy that's possibly available on every day of the year, right? So we're really talking about the coldest days and the hottest days of the year. If you're on the East Coast at the end of January, there was a really, really cold spell here where it was sort of this winter peak where lots of electric heat pumps and other electric heating tools were being used. And that really was sort of peak capacity almost for the year. Obviously, in the hottest days in the summer, we've got air conditioners and things and electric heat pumps as well, best case scenario. So in those cases, the denominator is really the maximum capacity that is needed because that's what everybody's building for, those hottest and coldest days. It starts feeling a little bit silly the rest of the year when it's like, well, we might be at 40 or 50 or 60% of capacity, but nowhere near what we built for. So to that end, getting more out of the existing infrastructure really stops us from having to invest lots and lots of money and time and carbon in building more generation.
I found this part really interesting to me because I come from a systems engineering perspective where there's actually the same issue. If you're thinking about provisioning your Kubernetes clusters, for example, there's a large amount of resources that go underutilized. I think on average, there's around like 70% of your cluster is not utilized. And this is similar in general when you build these systems. There's this principle of you're trying to close the peak to average gap. So for platforms that you build, you provision for the peak is the idea, but the use that you get out of the platform is the long-term average. So that's the same with these energy systems. They have to provision for the peak load. They have to have the capability, the infrastructure, the hardware for that, and the electricity for that. But in reality, what, the average user is getting out of the grid is what they're able to get on average. So I think closing that gap is a problem that we're every day solving. I'm trying to solve it through serverless, and by, time switching, so that you try and get people to use the grid when less people are online in the grid. So it's very interesting that we're seeing the same problems in the physical world and in the digital world. And maybe some of the approaches we take in the digital world can be transferred to the approaches we take in the physical world. And if anyone's interested in looking at the software perspective of closing the peak to average gap, there's a really interesting article by Mark Brooker on this. He's the author of AWS Lambda that I always point to, and it's on his personal blog, and kind of what got me really interested in this concept.
I love this parallel because it's like we need automated scaling for the electrical grid, but really what we have is people sitting in a control room turning switches on and off. And if we did that for servers, we'd be very, very busy a lot of the time.
Interesting. Oh, go ahead.
I was going to say this kind of links back to our episode from a couple weeks ago when we talked about the idea of applying kind of the internet protocol idea to the electric grid. The way that could make it so that we could scale is that you can add new nodes to the grid. So someone could join the grid when we need more and someone could leave the grid when we need less. And the idea of, like you were saying, Ryan, being able to scale up and down.
Yeah, it's so interesting. And one question that comes to mind, I've heard so much about in Virginia in particular, how this affects people relative to the region, not the users of the energy, but the people who have these data centers in the backyard. And I've heard coalitions in the opposite direction, not from the hyperscalers, but the people who are kind of like not in my backyard. And I'm just wondering, Ryan, if you've heard anything about how this affects that coalition of people.
Sure. I mean, there are a lot of organizations moving against data centers in Virginia and around the US. I think every community is a little bit different. Even where I live in Loudoun County, in the heart of this conversation, I drive past 20 data centers on the way to the grocery store, but I can't hear them. There are other neighborhoods where, because of the way things have been zoned and built, the data centers really do back up to people's backyards. And that's why I think we're looking, especially in Virginia, where we've had a change in the state government recently, we're looking at tighter regulations on what you can use for backup generators, incentives to take away tax breaks for companies that don't use clean energy for backup, that stick with diesel, for example. So there's progress being made. I think there's definitely a lot of NIMBY activity, and I don't fault people for not wanting a data center literally in their backyard. It's really I'll say there are a lot of trade-offs. In Loudoun County, data centers provide a remarkable portion of our tax income. So I sort of walk around saying like, well, we've lived here for 16 years. Data centers paid for our kids' public schools. It's a little bit tricky in that regard, but I don't really fault anybody for who can, see the cooling towers from their steps, as we can often see the construction cranes who want to fight against that a little bit. And I think it's important to talk about where the right place is to put these when it comes to carbon, energy, water, the existing grid. And I think there are a lot of people trying to do good work in that respect.
Yeah. Thank you. This kind of ties back to a discussion we had last week about the water in the Greater Lakes area. And I hope next time we record, I'll have another story about water. But moving on then, the next discussion we wanted to have today is about the energy effects of the war in Iran. Ryan, do you want to tell us a little bit more about that?
This is changing like by the hour, so I don't want to generalize too much, or maybe I should generalize and not be too specific. Everything that's going on with the Strait of Hormuz, right? Stopping, sort of whenever the U.S. goes into an ill-considered war in the Middle East, the first word out of everyone's mouths is oil. So yes, oil is impacted, like gasoline prices are up. Okay. That's sort of to be expected. I think what's been a little bit of a surprise to people is the amount of natural gas, of liquefied natural gas that flows through the Strait of Hormuz to Europe and to East Asia, especially. So countries like Korea have been really strongly affected when it comes to prices. Countries like Italy, where they happen to get a lot of their natural gas through that route and still use a lot of natural gas on their grid, prices have gone way up there. So everywhere in those regions that are getting most of their natural gas from the Middle East have seen big increases in prices. And, it's very easy to look back to 2022, which feels like just a few minutes ago, when Russia invaded Ukraine. And we saw the same sort of spikes, and we saw some countries in Europe react. And apparently, if you're still depending on natural gas for energy, any sort of activity in this region is going to drive your prices up. Waiting to see what happens in the US. In theory, we're still a large exporter of liquefied natural gas right now. You can sort of watch the market and see what happens because of that. But at least in 2025, even without this activity in the Middle East, prices went up for natural gas because we were exporting so much. So I think there are a lot of secondary effects of this sort of thing, secondary and tertiary, and things that will last for years in the future, just when it comes to the price of energy.
I'm curious, Ryan, if you think that there is a possibility that this could motivate certain regions to transition off of natural gas-based energy. I think you mentioned some regions that might already be predominantly have data centers, for example, that are powered mainly on natural gas energy, and if there's any historical pattern here of this motivating shifts?
I hope so. I think it's definitely the kind of global action that when these things happen, even at a global level, at a local level, when there's such a strong impact that drives prices up to the point where it becomes a real problem. It's always a problem, but a serious problem, not just for individuals or for organizations, but for whole nations. I think that's when we see action really inspired. I just this morning saw a breakdown of where South Korea gets its electricity from or what the fuel sources are. And a really large portion was from natural gas, and most of that was imported. So they're impacted more than we might think about here in the US. But only, I want to say 20% of their energy was from renewables. I need to check electricity maps to check this data. But I think that's a good example of somewhere that has lots of battery and renewables technology that they're building and maybe exporting. And maybe this is a pivot point where they start building a lot more and incentivizing more of that growth for themselves.
Yeah, I would love to see this be a pivot point so something good can come out of this. Well, we're not going to talk about the politics here, but, I've even seen that there was calls for the UN to allow humanitarian aid through the Straits of Hormuz. And I'm not sure that humanitarian aid is in Iran's best interest, or I shouldn't say, is in Iran's interest right now. I'm not sure that much humanitarian aid. And as we know, Iran has an internet blackout right now. So who knows what's happening. But yeah, let's hope that renewable energy will come out of this. All right, moving on then to topic 3. Let's talk about PUE ranking. there were 2 articles that you shared about this, Ryan, just some raw data and what to do with this data.
I love PUE because this is the efficiency of everything in the data center that's not compute, right? And so when you look at companies around the world, I know Google's best, so I'll say like Google is often in the lead, but all of the hyperscalers are pretty good at this. You'll often see PUE expressed as a number like 1.20 or 1.07. I think Google's down in the like 1.0 single digits, which is pretty impressive. Like 1 would be perfect, would be that every watt of electricity that goes in is used for compute. So the fact that just, I guess, I'm not the math person, but maybe 7% is used for heating and cooling and powering everything else, I think is pretty impressive. One of the interesting pieces here, though, is if we're talking about heating and cooling, we're talking about where needs to be heated and cooled the most, right? So where you decide to put your data center, I think carrying on from the conversation about water, you can put your data center somewhere where there's lots and lots of solar energy, but it might be very hot and you might need a lot more water for cooling there. Or you can put your data center somewhere else that uses air cooling and uses a lot more energy to move that air around. So there are all these trade-offs, and looking at PUE is a fun way to sort of understand who is doing a good job, at least of keeping what's inside the data center as energy efficient as possible, keeping these external factors in mind.
Yeah, we talked last time about Arizona versus the Great Lakes region in terms of solar versus water. And exactly those kinds of trade-offs. And of course, there are regions like Iceland where perhaps it might be ideal, but not every data center can be in Iceland.
To make sure that I understand the definition of power usage effectiveness, it's my understanding is all of the energy going into the data center divided by the power needed to run the IT equipment in it. So the scope of that is like all the servers and hardware and cooling the data center. It's all of that. Is it inclusive of the formula, correct?
Yes. So you're taking into account what's keeping the data center running versus what is needed for compute. So when we think about making let's say a Google Gemini, request, and how much energy is it taking for the data center to generate that bit of inference? Well, that includes the compute, but then we also have to think about what's the efficiency of that whole building, right? What's it taking to, I shouldn't even say heat. Usually it's cool, right? To cool the rest of what's going on, to keep the lights on, all these other bits. But a lot of it really comes down to cooling methods. And I use Gemini as an example, but really like different data centers are used for different purposes. We talk about AI all the time now, but what's involved in AI training versus what's involved in AI inference versus what's involved in just standard cloud computing that we've been using for many, many years and think about every day. These are all different load profiles and different cooling profiles as well.
Do they somewhat match up to scopes, like scope 1, scope 2? Any manner of thinking?
That's where I'll say, like, it depends. It definitely depends when it comes to especially scope 2, like the carbon emissions of electricity in the GHG protocol. When we look at data centers, often we're looking at whether the sort of owner or operator, or is it co-located? What's sort of the boundary for your scope 2 electricity is really about what you're paying for. As soon as I am a customer hosted in a co-located data center, it becomes scope 3 for me. So at that point, it's sort of what's in my supply chain, right? What is the person that I'm paying for services paying for electricity, and what's the carbon emissions of it? So that's where the difference lies. And that can come into play, especially if we're talking about the PUE of a data center that is that I'm hosting in a co-located scenario is not something that I have control over as an engineer, an architect, a platform developer, right? All I can control is sort of what's in my racks.
And I think your resources that you linked were interesting too, because it not only showed the PUE of all these different companies' data centers, but I think when you stack that on top of the efficiency of their compute, it's a bit of an exponential formula there. So Google, we've mentioned because it's kind of top of the chart. of the like November 2025 link you shared, which showed that a 1.09 PUE. But then also, if we're talking about those data centers that are focused on AI workloads, Google uses a lot of TPUs, which are known to be more efficient than GPUs when tailored AI and ML workflows are put on top of it. And so you get better watts per flop performance on top of a data center running with better PUE. And so that can, compound. And if data centers are able to make one choice to optimize PUE and then optimize their software and hardware as well, we get those benefits compounding.
I think watts per flop is a really fun metric right now.
I'll ask another question. This information is really interesting. Is it complete? I hear a lot about what these organizations share and don't share. So you talked about things like AI training. Do we have information about that?
It's limited. If you've ever seen me talk about the sustainability of generative AI, it's something that is a current and constant problem, I would say. Not everybody is providing transparency into their energy usage, the carbon emissions of it, their water usage. We don't know necessarily where things are being trained and when and what form of electricity was on the grid at that moment, unless they disclose it. Google put out some very interesting information in a paper last year, I want to say late 2025, about energy and water use of Gemini. And it was impressive numbers, not just because they were, I'll say, just sort of like subjectively good, but also that there was improvement year over year. We have no parallel for that data from any of the other providers. We have a totally different bit of data from a French company, Mistral AI, used different units entirely. So when you were saying watts per flop, that's sort of standardization. And I'll give a shout out to the Green Software Foundation folks that worked on the SCI, Software Carbon Intensity Specification for AI, the SCI for AI. That's one of the first standards specifications that really is trying to lay out, here's how you can measure the carbon efficiency, right, of AI and what the emissions look like. There are lots of sort of standards in development, and I think it'll be interesting to see what is that core metric, like watts per flop, that we can use to determine this is what energy efficiency looks like for AI.
I'll also call out Sasha Luciani's energy score, which I know she's been pushing for people to adopt, modeled after Energy Star, kind of an energy rating, like we have appliances. I believe Mistral used.
Yeah, Sasha Luciani and the team at Hugging Face have done a lot of really important work around this. It's mostly focused on energy. Carbon is, downstream of that and trying to see. That's when you need to start knowing the when and the where. In the case of something like Google Gemini, when did you train the AI and where did you train it becomes a very big coefficient on what the carbon, the overall lifetime carbon emissions are of Gemini. I heard an interesting anecdote from some researchers around last year this time at San Francisco Climate Week that some folks had put out a paper saying like, hey, this is what the emissions of Gemini are. And Google had responded saying, actually, we trained this particular model in the Pacific Northwest on lots of hydro, so it was pretty clean. So you're off by a couple orders of magnitude. That sort of transparency is needed, and it's needed in a standardized fashion so we can compare apples to apples.
I think that's been my experience reading a lot of the research being put out on carbon intensity of AI and the fact that a lot of the research has been caveated with paragraphs of these are our assumptions. So we don't have the data, but we're going to assume it's using this much clean energy, or we're going to assume 100% liquefied natural gas. And I think that is the way they're getting around not knowing, because we just have a lack of data around what some of these the energy sources of some of these hyperscalers data centers when they're not exposing it. And I think those caveats are necessary. And then you can basically redo their formulas when you find the facts.
Yeah, we often say all models are bad models, but something is better than nothing. Sometimes I wonder if something being better than nothing is actually true. I have a friend who just showed me a template he's working on, and maybe when he has it a little bit more advanced, we'll invite him to talk about it, with disclosure, a disclosure template to include in various things of just what information you have about sustainability, including things like how we built the models, what the energy consumption, all sorts of information. And he really just spun it up, and it's available to whoever wants to see it, but it's very early stages right now. That would be tremendously helpful to all of us. So we'll get it here. All right, let's move on to talk about Markdown and crawlers.
So this is one that I spotted because in previous roles, I was working at an enterprise hosting company in the WordPress ecosystem. And that means that I paid a lot of attention to what was going on in the Drupal enterprise ecosystem as well. So the Drupal founder, Dries, has shared a lot of interesting information over the years, especially about some personal experiments that he's done. But he did something recently that we'll link to in the show notes, where he tried to measure what AI crawlers were doing on his websites. There's a lot of good ideas out there about what you should or shouldn't tell the bots to do when it comes to AI. I certainly worked with customers in my previous role where large corporations who published a lot of content wanted to block all the AI crawlers. And then, of course, they made deals with them to get paid for access to their content. I won't mention any names there. But what Dries did here was really sort of test these assumptions. A, are the robots listening if we tell them don't index us? That's a pretty important question to answer. And B, he was looking at what some best practices people have talked about for, I guess are we calling it AEO, AI optimization instead of SEO? I think that's real, maybe, but I'm not sure. But one of these ideas, this was new to me, is about putting a certain markdown file or putting your content into markdown so it's easier or faster to scrape. I just don't know if that's true. Kate, you've got some insight into this.
Yeah, so I work on a CDN essentially. And so these are customer requests. And your point is important. And I really love this article because the way that he went about it is he basically duplicated the content of his site by also rendering .md pages as well. So the idea is that a crawler could go in and scrape just the .md pages, but that also means that Google Index is also indexing twice as much content, which means Google can get to indexing less content. So that's a separate issue, and it's an energy issue there too. But one way that people are trying to get around this is dynamically rendering the markdown equivalent of pages and putting the CDN layer in front of that. So basically, an HTTP request would come in, and in a request header, you would say accept markdown as the text type, as like the type to return. And on the CDN, it basically will fetch the HTML, convert it to markdown, and return that. And then it could cache that. So then next time it just serves it from the cache. Or another way of doing it is you basically, if they receive a request for a page, so basically like mywebsite.com/foo would return HTML, mywebsite.com/foo.md, the CDN would automatically convert to markdown. And so that's something that Cloudflare has support for. And then with Akamai Functions, we have some example WebAssembly applications that can do that on the CDN edge for you. And you just deploy that function and it basically sits in front of your origin and does that conversion dynamically. But it's interesting because what the article you shared showed is that crawlers aren't asking for the .md page. It didn't talk about whether crawlers are passing this accept markdown header. So I'd be curious in seeing some studies on whether they're trying to use a header to first see if a site supports kind of that dynamic conversion of pages. But one thing that he does mention in the article is maybe we'll see this in the future. I mean, things happen so fast. So just because agents aren't prioritizing doing this now, maybe, in a few iterations, we'll see them start to care about this, and it'll save, the agent's time and also energy and tokens if it can just fetch the right content once.
There's a lot happening in the standards world that's like adjacent to this. Not necessarily Markdown, but trying to signal something to SEO or AI, and sometimes that's the same thing. In the IETF, there was work called AI Pref, AI Preferences, which is indicating that yes, AI is allowed to call this, no, AI is not allowed to call this, or a lot of other things, but that's kind of an expansion of robots text. In W3C, there was work happening called TDM. It was about text and data mining, which this work started before the big AI boom. It was in response to EU legislation about text and data mining, which was put in the copyright directive. And then it kind of pivoted to include some information about AI. And then just this week, I heard about a group that is being formed to include information at a tag level about whether content was generated by humans or AI or some combination thereof. So that's kind of a different area, but people want to know who created this thing. And that was the proposal there, is to be able to include that at the HTML tag level. So like I said, adjacent, not exactly the same. And is that for humans or for robots to read? I'm not exactly sure what the goal is.
That last piece about, I'll say, micro formats, right, really reminds me of some things that news organizations did, and that we've seen even kind of coalitions from folks like Adobe doing when it comes to provenance of images.
I've been involved in the C2PA work. So they've C2PA in this. That's the Coalition for Content Provenance and Authenticity, I think. I did a workshop with W3C about credible web stuff, and I'll talk about, there's a lot to do about. But, C2PA is very involved in this, also at the content level. It's more about images than text, but they're expanding into text.
And if you want to see what the conversations look like from a very consumer sort of perspective, the is this AI, I don't know if that's the right name, but the subreddit where people are posting pictures and asking, is this AI? Sometimes it's educational, and sometimes I just sort of throw up my hands like, this is Photoshop. Like, it doesn't have to be AI just because somebody swapped a face. But still, it's interesting to see everyone trying to understand provenance. And I love the idea of getting control, of course, of understanding like, what is my content being used by these AI companies. But I also feel like I feel like we might be a little bit late to the conversation when it comes to standards. And so I applaud the work that Kate, that like Akamai and Cloudflare are doing, because the folks who have that gatekeeping capacity at the edge are really in a position to block things. And that's where a lot of those controls, I think, are going to live.
Absolutely. I will say that it's a little bit late for standards is pretty much the conclusion that everybody's come to, except for C2PA, and there's an organization in Japan called Originator Profile that has a similar conclusion. However, that might be the case for like, is this AI? But there's a lot of like in the middle space where like, oh, there's a false review about my product on seller.com. What do I do about that? There's a lot of stuff out there that's false, which isn't necessarily AI. And it's kind of like we're kind of moving away from the conversation that we're supposed to be talking about today. But there's a lot to discuss. So getting back on topic, LLMs and Markdown, interesting topic. There's been a lot of work in talking about measurement, and we touched on this a little bit before, but I misquoted. It's not green energy, it's web energy. But there's also been a lot of discussion in organizations. There's an organization called CarbonDB. And the idea behind CarbonDB is that a lot of components in your stack produce different amounts of CO2 based on how much energy they consume, how long the hardware is used, what time, and where certain operations are computed. and lots of other details. And this really goes hand in hand with what we were talking about with data centers and timing. It's really important to be able to record whole data for improvement purposes, but also for reporting. And CarbonDB is a method that they're trying to provide information tools for this, metrics for this. I'm wondering, Kate and Ryan, if you had an opportunity to look at this. There's a lot to prepare for this episode.
When it comes to hardware, I think efforts like this and like the, I want to say Open Compute project protocol, something with P, are doing a lot of the hard work of sort of building, if you can imagine the spreadsheet of every possible hardware component in a data center and what its embodied emissions are, right? Like how much carbon went into creating it, how much carbon will go into recycling it, or how much other chemicals will it emit when it's in a landfill. Those efforts are fantastic because it gives us all of this data to go into the rest of our calculations. I think it's really important, especially at scale, when you start looking at the size and scope of some of these data centers that are getting built and the energy that's getting used. I think understanding the hardware is really important.
Yeah, and there are a few other tools that have been shared recently. And I think we can talk about them in the future. Kate, did you want to add something?
Yeah, I just wanted to say things like CarbonDB are really interesting because they are providing an ability to have visibility into the, resource intensity of, a variety of software. Like that is an immense goal. And I think one of the things that I like about serverless and working on it is that we reduce the scope of what we're measuring. And we also reduce the accountability of who's responsible for that. So one of the things that we're able to do with WebAssembly is that for every execution of a function, we can measure how much CPU time was used and how much memory was used for every single request. And we can bill on that. And what that means is that the software engineer who's writing that function may pre-initialize data because they don't want to use extra CPU time of processing the data upon request. Or you can do all these different things and you can measure locally, that performance and then deploy it. And you're reducing the carbon intensity of your software, and then you're also reducing your bill. And so the incentives are aligned there in a powerful way.
That's really interesting. I feel like I need to take a deep dive into WASM. You always pique my interest.
And I would say this isn't WASM specific necessarily. So any type of serverless, I assume, micro VMs with AWS Lambda, they likely can, track CPU and memory usage per request. It's the idea that platform as a service, when you have that, you have a platform that is measuring things granularly because it's a multi-tenant platform and they have to. And so that helps. But obviously, if you're running your own microservices or monoliths, you're paying less attention to what software engineering team A is doing, their microservice versus microservice B, because we're just trying to ship code.
I have been in that picture and I didn't like it. Getting that more granular data is the thing that unlocks, right? For certainly if you're doing platform as a service, that unlocks being able to give those customers more granular sustainability data about the services they're using, where they're using them, when they're using them. Because if everything is just sort of plugged into the same wall, it can be a little bit challenging. So looking at that at the request level is a great way to go about it.
And I think I would point out some caveats. We're giving someone the exact usage of their execution, but that doesn't include, all the supporting services of the platform, right? So it's still a vast approximation for the software carbon intensity, but it is a relative approximation for their own function.
Okay. I think we have time for one more article. In the UK, it seems that data center developers are being asked to disclose their effect on the UK's net emissions. I think this ties in nicely with a lot of the discussions that we've been having. So this is kind of calling on, I don't know if it's individuals or organizations to prove that their projects not only don't increase net emissions, but are doing something to improve what's happening in the UK. So it's not clear if this is like service, if this is work-linked carbon, or if this is a bigger issue. I'm not sure exactly how they have to prove those numbers, but it's pretty interesting that the UK has this goal for developers to show that they're not causing damage and possibly even show that they're improving infrastructure. So I think the UK is working to show that in aggregate, the climate impact is improving digital infrastructure.
I think it's interesting there. They're leaving the door open a little bit for the folks who want to talk about the AI for sustainability as opposed to the sustainability of AI, right? The idea that you can use new artificial intelligence techniques to help reduce carbon emissions, to help get closer to net zero. While, of course, I think that's true, I think it might be more difficult to prove in the short term, as opposed to something that's very measurable, like how much natural gas are you burning for that data center. So I'm excited to see them asking for more transparency and disclosure. I don't know exactly what type of responses they're going to get.
Yeah, but the UK definitely is a leader in this area with reporting and having some regulation tied to the reporting. All right, so we have some events to talk about. I am not great at my pronunciation in some of the European languages, but I'll do my best here. On March 25th at 7:15 Central, there's a virtual research meets practice session with Asif Khan and Bill Nordberg. LUT at Sustainers. Somebody correct me. I think it's French. We have UX Jumpstart on March 26th at 2 o'clock Central. Also a virtual workshop designing products that drive real climate action using lean UX and planetary boundaries thinking. And finally, if you've recently spoken about green software at an industry event or have an event coming up, please let the team know via the link to our forum in the show notes. We've come to the end of this episode of This Week in Green Software. Just a quick question before we go. What's the most unnecessary thing people do online that secretly drives you a little bit crazy? I've got one of you. I find that the use of, it's usually ChatGPT to like make those animations generally based on some original artwork to be just like, or even videos, very energy consumptive. People don't know what they're doing often, and then if you tell them, they're like, no, that's not really true. So that's my number one. How about you?
I'm a little bit, old school. Like there's nothing that will make me bang my head on my desk harder than a good old fashioned reply all apocalypse. I think we've all got scars. We've all been there. Maybe we've all benefited from something that should have been in BCC, not being in BCC. But really that moment when you see people responding to a long list and it's usually them asking to be taken off the list. I, respect the need and the pragmatism, but also, it's okay to do that privately.
It's a good one. Kate, go for it.
I think mine might be similar to yours, Tzviya. I do not like it when people ask LLMs to make recipes for them. I love recipe cookbooks. I love online like recipe bloggers, and just asking, ChatGPT, give me a brownies recipe really upsets me. So that would be my irksome little point there. If you need to convert, like make your own brown sugar, sure. Ideally ask Google with the minus AI, how do I convert sugar to brown sugar? But if you really need to ask an LLM that same question, go for it. But the entire recipe, I would prefer you found a different source.
In kitchen forever, but Ryan looks a little upset.
I would be so terrified about the hallucinations.
I don't know. I know a lot of people who will do like meal planning with LLMs, but meal planning did exist before ChatGPT.
Shout out to cookbooks.
Yeah,
cookbooks.
Once upon a time, in a different lifetime, I edited cookbooks.
Oh,
Different life.
that's huge.
All right. So now you know what kicks us off. And thank you for a great episode.
Bye, everyone.
Bye.
Thanks so much.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.